Good afternoon, everyone. In the last lecture, we have discussed the examples on a combination. Yes, so these examples are very basic, which are depends on the formula n factorial divided by r factorial into n minus r factorial. Yes, now today we will see the combination with repeated elements, but before that we will see some examples also we can solve by using the basic formula. So see here the first example. How many triangles can be obtained by joining 10 points, 3 of which are collinear? So the example is similar to in the last lecture we have already discussed the example on a plane. There are 10 points are there and 5 points are collinear. Then how many ways you can form a lines joining these joining these 10 points? Yes. So this is example is also parallel to that example we are already discussed. So see here, just you can read it again. How many triangles can be obtained by joining 10 points, 3 of which are collinear? So already you know what is meant by collinear points. So those points which are lies on a straight line or a single line, then that points are called as a collinear points. So to form a triangle, we need to select 3 points. Is it clear? If we were to draw a triangle, then we need 3 points. Yes. Here 10 points are given and the condition is there are 3 points which are collinear. Means we have to form a triangle, we need to select 3 points. If no points are collinear, then how many ways you can draw a triangle? So there are 10 points, it means that 10 see 3 ways. Why we can take here 3? Because we need 3 points to draw a triangle. Yes, that's why there are already given 10 points, and if no any point is collinear, then the possibility is to form a triangle of these 10 points is in this way. 10C3 is equals to 120. Yes. So however, but in this example it is given that 3 of these points are collinear. Yes, they do not form a triangle. Why? Because all these points are collinear, means these points are in just on a straight line. So the number of ways to select these 3 collinear points is 3C3 ways, and it is equals to 1. And thus the number of triangles that can be formed by joining these 10 points is, already we have calculated the formation of a triangle without any collinear point, and it is 10C3 ways, and the answer is 120. And just you can subtract 3C3 ways, because the number of ways to select these collinear points is 3C3 ways. Just you can subtract, we get 190 distinct triangles can be formed by using these 10 points, out of which 3 points are collinear. Yes. So this is a very simple example. Now let us see again one example on this basic concept of combination. So this one is the example. In an election, there are 10 candidates and 3 of them are to be elected. So to how many candidates can a voter cast their vote, provided the number of votes does not exceed the number of persons to be elected? So in how many ways can be voter cast their votes? So read again. I pause here. Just read it. So see, in an election there are 10 candidates and 3 of them are to be elected. It is clear. The second thing is given here, how many candidates can voter cast their vote, provided the number of votes does not exceed the number of persons to be elected. It means that there are maximum 3 votes are there to be cast their votes. Yes, because 3 candidates we have to select out of 10 candidates. So the number of ways to cast the votes is calculated as, so let us see. So this is the case number 1. the voter cast a vote for one candidate. Means there is only one candidate, and out of 10 candidates only cast their vote for one candidate in a 10 C1 ways. It is equals to 10. Second case is the voter cast votes for two candidates, so it is 10 C2 ways, and it is equals to 45. And the third case is the voter cast votes for three candidates, and it is a maximum. The condition is given already in the example. The voter cast their votes not exceed to the elected candidates. Yes, and we have to elect three candidates. So it is a 10C3 is equals to 120, and thus the total number of ways in which the voter cast their vote is equals to, just you can add 8, we get 10 plus 45 plus 120, and so there are 175 different ways for the voter to cast their vote. Yes, so here we solved two examples on concept of combination. Now let us see the concept when the combination with repeated elements is allowed. So already we have discussed here this concept in a permutation also, permutation with repeated elements. So the same concept is we have to apply for a combination. It means that in some situation we want to select elements from a set where each element can be chosen more than once way. This type of selection is known as a combination with repetition. So in this scenario, the order of selection still does not matter. Yes, but each element can appear multiple times in the combination. So let us see here the following examples on a combination with repeated element is allowed. So this is the example. Suppose you want to pick a 4 fruits from a set containing 3 types of fruits: apples, orange and bananas. Assume that the order in which the fruits are picked doesn't matter, and that there are at least 4 fruits of each type. So read here again carefully. I repeat again, there are 4 fruits of 3 types. What are those 3 types? Apples, orange and bananas. We have to pick up 4 fruits, and each type of fruit is of 4 types. Yes, means 4 apples, 4 orange and 4 bananas are there, and we have to select 4 fruits. And here the repetition is also allowed. Yes, so how to solve this example? So there is a very interesting method is there to solve such type of example, and that method is a star and bar method. Yes, so what is this method? Just see, there are 3 types of fruits: apple, orange and bananas, and 4 fruits of each type. Yes, can be selected as many as 4 times, because already there are maximum 4 fruits of each type, and here the repetition is allowed. So you can use the method of star and bar to find the number of ways to make this selection. So suppose that the box has a 3 compartment, and it is given in this figure, and it is separated by dividers. Yes, so if you observe this figure, the first box contains apples, in the second box contains orange, and in the third box contains bananas. Yes, and all these 3 boxes are separated by, yes, a divider. After that, if you see, we have to pick 4 fruits with represent a 4 stars. Means there are 4 stars are there. Now to divide the stars among these 3 types of fruits, we need 2 dividers. 2 dividers are there, or we can call it as a bar also. So each arrangement of stars and bar represent a different selection of fruits. So see here this second figure, so you can clarify the concept. So if you observe here, in the first box there is only 1 star, in the second box there is 3 stars. So it means that 1 star is for apple, so you can select only 1 apple. 3 stars in a second box, it means that we have to select 3 orange, and the blank box is there, means we need not select any fruit from this box, or you cannot select banana from this box. Yes, and in the right hand side of this figure, the two separators or dividers, or we can call it as a bar also, is there to divide these stars. Yes. So in the second possibility, sir, you can select one apple, two orange and one banana. Yes. And in the third possibility, you can select all the four apples. Yes. So in this way, by using this star and bar method, you can select the elements. Yes. So see, to find the total number of ways to arrange these stars and bars, you know the 4 stars and 2 bars to arrange in a sequence. So the total number of positions are 4 plus 2, it is equals to 6. Just you can arrange it, and look at here in this figure. So the arrangement is here 6 times. This is the 1, 2, 3, 4 and 5 and 6. Yes. So 4 stars and 2 bars. These are the 6 positions. Hence the number of selections of 4 elements, a set of 6 elements, which is equals to 6 C4 ways, and you can easily calculate 6 C4 is equals to 15, and therefore there are 15 different ways to choose the 4 fruits, and 3 types of repetition is allowed. Yes. Now from the above method of star and bar, we will see here the theorem, or you can prove this theorem by using the star and bar method. So let us see here the statement of this theorem. The number of ways to choose R elements from a set of n distinct elements with repetition allowed is given by n plus r minus 1 CR, and it is equals to n plus r minus 1 factorial divided by r factorial in another bracket n minus 1 factorial. So we have to show this result. So how to show? So first, to derive this above result, we use the star and bar method, which helps in distributing R identical elements into n distinct groups, where each group can have a 0 or more elements. We need to choose R elements from a set of n distinct elements, where each element can be chosen multiple times. Yes. So you know already we have solved the example of star and bar by using this one to select the 4 apples. Yes. So these are the 4 distinct compartment, 2 distinct compartment for selecting the 4 apples. So hence the problem is equivalent to distributing the R identical elements, means stars, into the n distinct groups. It means compartments, and these compartments are separated by bars. Yes. For example, already we have solved, if we have to choose 4 fruits from 3 types, apple, orange and bananas, then with repetition is also allowed. So the distributing these 4 identical stars into 3 distinct compartments, we have to select R identical objects.